So what Cory's doing right now is he's removing each individual burner tube, cleaning out all the orifices in them so we get proper gas flow and proper ignition. They're packed full of spider webs and debris just from being outside their whole life. You know, they live on the roof of an industrial building. Nobody's up here washing these things off very often. So one of the other things that we're gonna do is once we get all the burner tubes out, we're gonna clean the flame sensor. What the flame sensor does is it proves to the circuit board in the unit that not only did we attempt to light a fire, that we actually lit the fire and it was a successful ignition. So if that flame sensor doesn't read that the ignition was successful, the unit will go into what's called a lockout, and it'll basically shut itself down to prevent gas flow that's unnecessary. So there's another burner tube. You see how it's all packed full of debris. So those orifices are where the gas and the air flows through that burner tube, and if you have those restricted, it's not going to run properly. Super components. Super important components that we check is the fan motor and the belt and the pulley system. So this is your fan drive motor, this part over here to the right, and then you have the actual fan itself, or the squirrel cage as a lot of people like to call it. I'm sure you can imagine why it's called a squirrel cage, because it looks like a big hamster wheel. These belts, they don't, when it comes to actually driving a motor with this style of system, it's called a V-drive. Now, this belt has a taper to it. What drives this belt is actually the sides of the belt, not the flat part in the center. So what happens over time is if you look at this pulley is pretty wore out. There's a pretty heavy groove in the side of it. It might be a little hard to pick up on camera, but this pulley needs to be replaced. Because what happens is if you don't have those two nice flat surfaces, you know, mating to each other, you're not going to get good traction on this belt, which is going to cause it to slip. And if it slips, it burns the belt up and the belt breaks, and now you got no fan. We check the pulleys on the motors, check the bearings for end play and lateral play. Make sure that those are all good, change the belts. We put a new belt on it every single time, no matter what. It is kind of funny though, whenever you open these units up, if you have a belt that's not broken, that's usually where you find it. Now, why do we leave all the old parts inside the unit? Well, because at 2 o'clock in the morning when you need to fix it and you don't have a belt in your truck, you're saving the next technician. They can at least get through the service call. It's kind of funny. We didn't leave this part. This was here when we opened the unit, but this is a gas control. We have no idea if it works. Maybe it kind of works. Maybe it works a little bit. At 2 o'clock in the morning, as long as it works something, it's good enough. So one of the other things we spoke about on the other side was the heater on the compressor. These bands that are wrapped around the bottom of the compressor, that's the heater. So what these do is these help keep the oil that's in the refrigeration system at an operable temperature, because when it's too cold, oil gets really thick, and that's how it can cause compressor damage. So between having this stuff so you can run it in a low ambient situation, the economizer, you know, that's how you're able to run these things when it's like it is today out. Right here, just this portion hanging off of the rooftop unit is what's called an economizer. So the economizer does have its own filter. Not something that really has to be replaced unless it's damaged, because it's an all aluminum filter. Basically, we just flip it on its back like this and hose it out. What an economizer does is, if you look in here, there's two flaps. So what happens is these flaps will open up under certain conditions. Look, for example, we're at a car dealership, so the whole front of the building is basically glass. There's many times where, let's say it's 60, 65 degrees outside, but the sun is shining. And when that sun is shining through those windows, you get what's called the greenhouse effect. So it heats up the interior of the building to, let's say, 75 degrees, you know, whatever. And it's too cold outside to necessarily run the air conditioning. So what an economizer will do is it'll open up these flaps, it'll leave the air conditioning off, and then it will pull that cold outside air in through the evaporator coil and then push it down into the building. So it's a way that you can achieve air conditioning without really running the AC. You're also saving a ton of power doing that too, because all you're running is the blower at that point. Um, this part right here, this is the evaporator coil while we got this panel open. This is another part that we clean. So this is the other half of the air conditioning system. You have your condensing coil and your evaporating coil. So this is the other half of that. This is what generates the cold air. Once you went through that heat exchange process going through the other coil, that's how you get your temperature drop, and that's how you get AC. Okay, so one of the other super important pieces that we inspect on these units is what's called the heat exchanger. So this is the heat exchanger that you're looking at here. This is the series of tubes. One of the things that we're looking for in the most common failure points is like right on these corners where these bends are made. So these tubes start out life as a straight piece of tubular steel. They are a seamed tube. So if you see that seam right there, basically they start life as a flat piece of metal and then it's rolled over and it's welded. So those seams are also a super common failure point because that's where the pipe was fused together originally. The importance of a heat exchanger, those first parts we talked about, the burners. So the gas and the fire basically goes into the heat exchanger, and then we blow air across the heat exchanger, and that's how we get our heat. Now, if you have any sort of a crack or a perforation or a tear or a rust hole or anything like that in the heat exchanger, the carbon monoxide from the gas being burnt is then being released into the conditioned space. So basically, if you look straight down here, this is your ductwork. So this is what goes out to the whole building in order to supply the heat. So if we have carbon monoxide leaking from one of these units, it's going down into the conditioned space where everybody's hanging out. And obviously we all know that breathing carbon monoxide is less than ideal. So super, super, super important part of the heating system, super important part that has to be inspected. And it's definitely a safety concern. It's not just a breakdown concern. So this is one of the highest priority items on the list. Cool. So these right here, these are exhaust fans. There's a bunch of them. There's 1, 2, 3, 4, 5, 6, 7, 8, 9. I don't know. There's a bunch of them over here. We did also remove all the covers on these. We inspected them. Those are set up similar to that condenser where they have a drive motor and a belt. So we put all new belts in all these just to make sure that the stuff stays working. So if we come over here real quick, I want to show you something. All right. So up here on the roof, that trailer, that's our drain cleaning trailer. So our drain cleaning trailer, what's in there is, so imagine if your little pressure washer at home did nothing but eat chicken and rice and go to the gym every single day for like 10 hours a day. That's basically what's in that trailer. It's a big pressure washer. We've got about 50, 60 gallons of water in there at all times. It does have a reel that we hook up to the building so it can constantly refill that water storage. But that's going to be that's our supply water, our supply pressure, so we can really give these units a good wash down. Pressure isn't the only thing that you're looking for, though, when it comes to washing down these coils. You need volume. You need water flow to actually move that debris. So your typical, pressure washer at home, let's just say it's, 2 gallons a minute or something like that. It's pitiful by comparison. This pressure washer can run at about 3,500 PSI and about 12 gallons a minute. So having all that extra volume to actually move the debris gets you a truly clean coil. So I want to talk about the debris that's on the outside of these coils a little bit more. Them being dirty, obviously, aesthetically, that's not our goal here. It's not, although they do look pretty when we're done, that's not the main focus. All this buildup on the outside of this coil restricts the airflow going through the coil. So all these little slots in here are the way that this thing, it dissipates the heat. So these coils get hot, the air goes through the coils, and that's how it loses the heat. When you have these restrictions, obviously your airflow is not what it's supposed to be. So that's how you end up, having performance issues. Units can't keep up because they're not breathing properly. And it eventually leads to a breakdown. It leads to a lot more stress on the equipment too. The equipment's got to run harder to do its job when it's not working efficiently. So what Cory's doing is he's spraying down the coils with coil cleaner. So it's safe to be used on coils because coils are aluminum. That way they won't corrode, give us problems in the future. You know, if you use any chemicals that are too harsh, you can actually damage the coils. So he's going to spray the coils down, let them soak for a couple minutes, both the evaporator coil and the condensing coil. And it also is a bubble machine. But we're going to spray them down, let them sit for a couple minutes, and then we'll get basically the giant pressure washer up here and get them sprayed off. All right, so what Cory's doing now, this is that coil that we showed you before that was completely disgusting and packed. You see the bubbles coming through. He's washing it from the inside out. So if you look at all that dirt and nasty water that's just rolling out of these coils, those are all the things that reduce your efficiency as the year goes on, you know, without the proper maintenance. So this is the last step in the process. We get in there, pressure wash everything, get all the dirt and debris out of the coil, rinse all the coil cleaner through the unit, and then we put the thing back together. And that's how we make it another 6 months, hopefully with no breakdowns.